Hello, I'm Amrita Chatterjee from Oregon State University, and today I'll be presenting our research an automated detector for gender inclusivity bugs on open source project pages. So, we all know about bugs in software, but there's a new kind of bug which is the inclusivity bug. An inclusivity bug disadvantages a particular group of users of a software, and gender inclusivity bugs, as have been shown in past research, are biased against users' cognitive styles. To learn the state of practice and what tools and inclusivity debugging resources developers are currently using, we conducted a survey with 266 open source developers. 77% of our respondents reported not incorporating any inclusivity practices. And among those who mentioned using specific tools, GenderMag got a maximum number of mentions. So, what is GenderMag? GenderMag enables developers to systematically find gender inclusivity bugs in their software. At the core of the GenderMag method are 5 cognitive styles. GenderMag uses 3 personas, Abby, Pat, and Tim, each of which has a different set of values for the 5 cognitive styles. For example, the Abby persona has a comprehensive information processing style and likes to gather information before acting, whereas Tim is on the other side of the spectrum and is a selective information processor and usually does the first promising action. So let me show you an example of a GenderMag evaluation. For this example, I chose the use case of finding an issue to work on. Towards that, I hope Abby's subgoal would be to find the issue list, and Abby's action would be to click on the issue button. GenderMag evaluators in our data reported there's nothing about the issue list, even though issue was mentioned in one of the sections. Evaluators pointed out that this is a situation where users like Abby would not find all the information they need to complete their task because of a mismatch to her information processing style. However, GenderMag can be expensive because it is an entirely manual process. GenderMag creators recommend that at least 3 evaluators should spend 1 to 2 hours per session, where a session usually covers only one use case. So that brings us to the question, can a tool help address this problem? Its ultimate goal is to automatically detect these gender inclusivity bugs. In this paper, we report our first step of automating a vertical slice of the GenderMag method. Specifically, this version of the tool uses a portion of all the components of GenderMag, one of its cognitive styles, one of its personas, and a portion of its scope, which is open source GitHub projects. So this is an overall architecture of the tool. It takes as input an Excel sheet containing the subgoals and actions that are to be evaluated along with the URL of the open source project page. Then it uses natural language processing to check against 5 decision rules to result in a text file with the violations. So, where did these decision rules come from? To derive the rules, we had to gather empirical data. We obtained GenderMag session data from 2 real teams, and researchers also conducted sessions on 18 more projects to produce data about the inclusivity bugs within these projects. These sessions led to a total of 276 inclusivity bugs. We then analyzed each inclusivity bug and the whys behind it as well as the user interface. That led us to 11 rules. Then, after 3 rounds of negotiated agreement, we merged these 11 rules into 5 decision rules. So now let's talk about the first decision rule. The first rule checks for situations where users like Abby would not find all the information they need to complete a task. The wording of the subgoal serves as the information Abby seeks, whereas the words from actions serve as cues to direct Abby to an UI action. It parses the subgoal in the action to get keywords to search for within the project page. Now, within the project page, to detect relevant information, we retrieve all the sentences on the web page that contain any of the keywords. Then, we use dependency parsing to extract the relationship between the keywords in each sentence. For example, here you see there is a syntactic relationship between issue and bug. So if there's a syntactic relationship between keywords, then it is considered relevant to the subgoal or action and does not report an inclusivity bug. Our results were really encouraging. Compared with the inclusivity bugs identified by humans, our recall was 92% and the precision was 69%, which proves that it did not report everything as a bug. We also broke it down by rule. As you can see, rule 1 has a similar result to our overall F measures. So, although humans performing methods in the cognitive walkthrough family report few false positives leading to a high precision, their false negatives run as high as 70%. But in this case, we see the opposite. So the reason behind high recall is perhaps that these rules implement straightforward comparisons, but we wanted to understand better why precision is at 0.69. So we took a deeper look into the false positives. 61 bugs among the ones that 8 had captured were not actually false positives. For example, in 27 cases, 8 reported a bug earlier than the team did. So that suggests this isn't a false positive because the team did find it, but not just yet. After we ran 8 on the 20 GitHub projects, we triangulated each kind of bug that was found by teams F and J that are found in the 18 GenderMag sessions that researchers conducted and the ones that 8 found. For example, in this one, the real world team F found one instance, J found this instance twice, whereas 8 found 11 out of the 15 instances. Overall, 8 found a total of 74% of the bugs that the humans found. To conclude, our survey's results suggested that tools like these are needed, as 77% of respondents reported not incorporating any inclusivity practices. A goal of this work was to find out whether it was possible for a software tool to automatically detect inclusivity bugs. And as our results with age show, such a tool is both possible and feasible to implement. It enables developers to find inclusivity bugs without needing to become GenderMag experts. I also want to add that AID is open source and we welcome contributions. Thank you for listening to my talk, and I'm happy to take any questions.
All right, so welcome back. With me are two authors of the paper, Amrita Chatterjee and Anita Sarma. And do please enter questions down in the chat box, and if you can, use the question symbol so that we can see that you're asking a question. So we do have a first question from Alexander. So great job. Would you expect, so we know that GenderMag supports a number of personas. Would you expect that the inclusivity bugs related to other personas and characteristics would be implemented or implementable in a similar way?
Yes. So this paper is also acting as a proof of concept, and we would expect to also implement other personas and cognitive styles in a similar way. But also that is something that's an interesting problem to tackle, and I will be working on that in the future.
Awesome. So I have a question about the precision. So precision is 69%, and at least in the paper, you broke those down into some of the categories, but like 61 of the 110 extra inclusivity bugs weren't really false positives, right? They were, repetitive reports of the same issue, or the system being hypersensitive. And do you have an early sense of whether this is addressable, right? Whether this would be easily fixed to have a quick increase in precision?
Yes, there are. These are the limitations of the tool that needs to be addressed in future work. Specifically, the tool right now, it does static analysis. Yeah. So that is one of the reasons that we couldn't. We had a couple of false positives there, but with respect to these exact bugs that you saw, where we were showing the ones where the tool was actually right. I think Um, it would not be as easy because it's we have to simulate a human, right?
Okay.
Can I add to that? Sorry. I
Yes,
would
go
just
ahead.
say, and this is a perfect case where just a label of high precision is not really the right answer, right? So the tool did better than the humans, and
Yeah,
therefore it did get the false positive, but it doesn't need the precision label in this case.
excellent. So we were talking a little bit backstage. So you've applied this to OSS websites, and curious about what the challenges would be to automatically apply this to other software artifacts. Whether it's other web pages or starting to look at other software artifacts and tools.
Yes, so that is a very interesting question. I do not know the answer to that. We are trying to figure it out, but also, so we chose GitHub this time because it is an information-rich environment. But when we extend that to websites, there are so many kinds of websites, so that will be very difficult to generalize and have a tool which works on everything.
Right. So is this part of your research? Is this part of your thesis? Like, is this part of your PhD thesis? And do you have
Yes,
a sense of how you're going to scope it? Because there is a wide range of things that you can scope it to, right? Whether you're sticking to web pages or whether you're going off and starting to look at software tools. Do you have a sense of how you're going to scope it?
so the ultimate goal would be to automate the entire GenderMag on everything, not only open
Yes.
source platforms. But we still do not know how we're going to scope it in the next step.
Yeah. So I agree. I think automating all of GenderMag is a large research project. It's probably going to be multiple PhDs. So I'll be curious to see what you end up doing. So Alexander asks about what if we just looked at ResearchR based conference websites, right, as sort of a next application.
Yes, we could do that, but so the problem with automating GenderMag is we need a lot of human data, and each session takes so much time. So we need to put that much human hours in to first get the data and then even see if it's working.
Right. Right. Anita, did you want
Another
to
question.
follow
I'm
up?
going to ask a question to Amrita. So, can you simulate some of this data? Is it possible at all? Because we have some existing real data. Can we use some kind of ML magic and try to simulate? Any thought?
Uh, right now, we do not have enough data for machine learning. This needs extensive amounts of data, like thousands, millions of GenderMag sessions. So
But
right now,
maybe,
whatever, yeah, sorry.
but maybe this is something you can talk to other, people who are doing ML, machine learning work on, generating synthetic data. I do not know much about that, but it would be interesting to see, if not from open source, but maybe for the research conferences, which are similar than open source projects are. And maybe we can look into synthesizing, like making synthetic data, and see if we could use that. And I don't know how to do that. So if anybody in the audience knows how to create synthetic data, that would be a nice, collaboration that we look forward to then.
Yes, definitely.
Yeah. And so what data were you using for the OSS websites? Like, did you have millions and millions of examples there, or did you manage with something smaller?
So we had two GenderMag sessions data from two real world teams and 18
Okay.
for 18 other projects. Researchers, the paper authors actually ran these GenderMag sessions themselves to generate that data.
Okay. So I think it is worth considering the ResearchR based conference websites? Because I don't know whether the data that was collected by the human studies of some researcher or conference websites is the kind of data that you need for your work, but it certainly has been applied manually to a number of researcher or conference websites. I just don't know whether the data that we collected from those studies is the kind of data that you need in order to feed the ML work. But something exists, and Alexander is right. I think there are a number of conferences that do use ResearchR. They're continuing to be interested in using GenderMag on their conference websites, and so I think you can easily find some example websites that where you could use the manual process to collect the data that you need in order to feed the automated process.
Definitely. I think I'll look into that next.
Awesome.
Thank you.
So what are you working on now? What's your work in progress?
Currently, so this scoping, even though it allowed us to investigate its effectiveness and its feasibility under these strict controls, but it still does impact its generalizability that, like you mentioned. So currently, we will be addressing the limitations of the current tool, and then the future work will definitely focus on extending aid to also evaluate for Abby's other cognitive styles, and also extending to the other GenderMag personas, Tim and Pat. And yeah.
Excellent. And so real quickly, is AID specifically for websites, or can it be used with other forms of documentation? This is from Paul Robinson.
Yes, so all of AID's rules can be applied to any open source project on GitHub and other hosting sites like GitLab also. But some of AID's rules, specifically the first 3 rules, can also work on any web app or web page.
All right. So with that, I'm going to thank the speaker and the author, and I'm going to invite people to carry on the discussion in the discussion room. So there'll be a button that pops up at the end of this. So thank you very much.